f of x is equal to ax cubed plus bx squared plus cx plus d. It has a maximum point, right? So the max point is at 0, 4. And a point of inflection, so there's a point of inflection at 1, 0. Okay, first thing, right, okay, before I do maximum point of inflection, any of that, right, okay, these points are on the curve, aren't they? So those points are on the curve, would you agree? Those points are on the curve, so that means I can just fill it in straight away. So this is x and this is y, right, agreed? So I'm going to just fill 0, 4, before I deal with the maximum turning point and the point of inflection and all that, I just know those points are on the curve, right? So everywhere I see an x, I'm putting in a 0. Everywhere I see a y, I'm putting in a 4. So 4 equals a times 0 to be cubed plus b times 0 to be squared plus c times 0 plus d. When you work all that out, you'll get 4 is equal to d. Okay, I'm quarter ways there, aren't I? Find a, b, c and d, I found d. Right, are we good? Right, okay, the next thing is 1, 0 is also on that curve. So everywhere I see an x, I'm putting in a y, I'm putting in a 1. Everywhere I see a y, I'm putting in a 0. So I'll get 0 is equal to a times 1 to be cubed plus b times 1 to be squared minus c times 1 plus d. I've just figured out d is 4, so I'm just putting a 4 there. Is that alright? Okay, so, say that again. Am I okay? It's plus c, yeah, sorry, thank you. Right, so I get 0 is equal to a plus b plus c plus 4. So I'm just going to change that to a plus b plus c equals minus 4. Right, I'll come back and deal with that in a while. Okay, I can't go any further there. Right, is that okay? Next thing I'm going to deal with is the maximum turning point. So at the turning point, dy dx equals 0. So when dy dx is equal to 0, right, if I fill in 0 for x, so if I get dy dx, right, let it equal to 0, right, okay, the answer will be, give me a minute, maximum turning point, dy dx equals 0. I'll just take it one step at a time and hope it makes sense in my head there in a minute. Okay, so I'm just going to do the turning point. So dy dx equals 0. So that would be 3x squared plus 2bx plus c equals 0. Right, okay? Sorry, 3ax, apologies. It should be 3ax squared. Right, okay. So the turning point is at 0, 4. So that means x is 0. Would you agree? Right, doesn't matter about the 4. X is 0. Right, would you agree? Right, okay, so everywhere I see an x, I'm putting in a 0. So 3 times 0 to be squared plus 2b times 0 plus c equals 0. Work all that out, c equals 0. Right, there we go. I'm halfway there because I now know what c and d are. Where's 4? No, that's when you take the answer, the x, and put it back into the original equation, you'll get 4. Right, okay, but we're good there? Right, okay, and the last piece of information was the point of inflection. So the point of inflection is 1, 0. So at the point of inflection, d2y dx2 equals 0. So, and x is 1. So x is 1 at this point. Doesn't matter about the y. Okay? So I need to differentiate again. Right? So differentiate there and you get 6ax plus 2b equals 0. Is that right? Have I that right? I have. Right, x is 1. So 6a times 1 plus 2b equals 0. So that's 6a plus 2b equals 0. There's a second equation in a and b. Yeah? Okay, are we good? Right, okay, then I have an equation in a and b already. I have a plus b plus c, but I've just found out that c is 0. So I can change that to minus 4 equals a plus b. Agreed? Because I figured out c was 0 there a few minutes ago, didn't I? Right, okay. So I'm going to multiply that by 2. Okay, right, when I bring it over. So I have 6a plus 6b equals 0. And I have multiplied by 2. I have 2a plus 2b equals minus 8. Agreed? Right, okay. So then I change the signs. Minus, minus, plus. They cancel. You get 4a equals 8. So that means a is equal to 2. Is that right? No. Have I right? I have. Right, okay. And then I'll use this. 6a plus 2b equals 2. So that means 6 times 2 plus 2b equals 0. So that means 2b is equal to minus 12. So that means b is equal to minus 6. There we go. There's a. So a is 2, b was minus 6, c is 0, and d was 4. 4. D was 4. Right? Are we good? There's a lot of maths in there as well, isn't there? Anyone get it right? Okay, it'll happen. Right, okay. Keep saying. Right, are we good? Yes.
Where did you get 3ax squared plus 2b?
I differentiate it.
Oh.
Right, so bring the power down front, reduce the power by 1. So the 3 comes down, 3a x to the power 2 plus 2b x to the power 1 plus c. Right, so differentiate it. And then where did I get this one? I differentiated again because it's d2y dx2. Right? Okay, are we good? It's hard. They're hard. These are the questions near the end of the exercise, so they're hard. But yeah. Okay, right, we get there. 18. Am I doing 18?
How do you show it?
Solve. And you won't be able to solve. Okay, so, right, so 18. It has no turning points. So x all over x plus 2. So at the turning points, dy dx equals 0. So get dy dx, right? So it's a quotient rule. So u is on top, v is on the bottom. Du dx is 1. dv dx is also 1. So it's the quotient rule, so it's v times du dx minus u times dv dx all over v to be squared. Sort that out on top, it'll be x plus 2 minus x will be 2 all over x plus 2 2b squared, right? And you want to let that equal to 0. Okay, so when I cross multiply, I'll get 2 by 1 is 2 equals 0 by that is 0. So you get 2 equals 0, which is like unsolvable. Unsolvable. So that means the turning point doesn't exist.
So is that how you show it?
Yeah, and then, yeah, point of inflection, you differentiate again. So you differentiate that and you let it equal to 0, and you'll end up with something similar, that 2 equals 0, which is not true and unsolvable. As in unsolvable, there's no x there, so how can you solve? Right, is that okay? Right, are we okay with that? Right, okay. Today's section, how am I going? Right, 11:36, I've loads of time because the next section is grand. Right, okay. So what we want to do is we want to do graphs of